Hello, my name is Sybil and my presentation is about cognitive apprenticeship. All right, so to begin, I'm going to give a definition. So cognitive apprenticeship is mostly about where a master and expert of a specific skill teaches that skill to an apprentice or a beginner. So in education, the master or expert would be the teacher, and the apprentice would be the student. The purpose of cognitive apprenticeship is to enhance learning and instruction. Okay, so within this topic, there are specific teaching methods that are necessary. The first one is modeling, which is where the expert demonstrates a task so that the learner has a conceptual model of the task. So the students have a visual of what they're going to do. Next is coaching. So the expert, which is the teacher, we observe the student with their tasks and we offer feedback. The third step is scaffolding. So this is where the teacher provides support to the learner to promote learning and for them to complete the task. The fourth step is articulation. So this is where any method can be used to get students to articulate their knowledge. So we want them to explain their reasoning or explain their problem-solving process. So an example would be inquiry teaching, where the teacher asks a series of questions. Or another example could be a think aloud, or another role could be a critical student role, where each student has a role in their group in a cooperating learning activity, and they all have to draw conclusions. The next step after this is reflection. So this is where the learner or student, they analyze their skill performance. The last step is exploration. So after everything is done, the student has to take the initiative to solve interesting problems, so they go beyond what they did. All right. So the article I chose, the title is "The Role of Cognitive Apprenticeship in Learning Science in a Virtual World." So in this article, the study exposed how the processes and methods in cognitive apprenticeship can be integrated in virtual environments to promote science learning. So pretty much what teachers are currently doing in the classroom, they're trying to put it in the video games, in the virtual worlds and virtual environments. And they believe that this is going to enhance science learning for all students. Okay, so what I did, I took some quotes that I thought had some key points in the research. So one is, students learn by doing as they observe an expert perform a task. So this would be the first step of the teaching method that I explained previously of modeling. So it really helps for students to have a modeling example that really helps them learn better. Another important point is that learning by doing a task enhances engagement. Engagement is very big right now. The research has proven that engagement is related to academic success. Students need to be engaged. So this virtual environment definitely qualifies and contributes to engagement. Another thing, expert is able to determine the amount of guidance various students need as they work on a given task. The good thing about the virtual environments is that the students can work at their own pace, and the teacher, we're able to guide them through it. And this is good because they have a direct and immediate feedback. All right. Okay, so like I said before, the apprenticeship model is a learner-centric and interactive. It's similar to a virtual world where learners have a sense of agency and can learn at their own pace, either individually or in collaboration with others. So this is great because the students, they can either work by themselves or in a group, and this is very similar to a classroom. Next, successful learning in this environment would enhance students' sense of possible selves and encourage them to pursue careers in the realm of science. So, virtual environments, they're very similar to the real world. With all the steps that I said previously, the teaching methods, if they're successfully integrated into the virtual environment, students can see themselves as scientists. And by being successful in this virtual world, they have the possibility of being successful as well in the real world in science, and hopefully will pursue a career in science. Okay, so next is cognitive apprenticeship and academic achievement. Online experiences and playing science games have the potential to transform students' thinking and understanding of scientific concepts. So the good thing about online science games is that students have the ability to perform tasks that they might not have been able to in the real classroom. So for underserved communities, underprivileged communities, some may not have the resources to actually have all the equipment in the classroom, and to accommodate for that, they can do this online. Next, designing educational games for learning is one important multimedia tool to foster engagement and promote active learning among students. So once again, the virtual environment will definitely promote engagement and learning among the students. Okay. Learning in a virtual environment. So the big idea here is learning by doing. So computer-based simulations can be designed to capture some key elements of cognitive apprenticeships. So these are the teaching methods that I said before: modeling, providing guidance, giving feedback, direct feedback, support, and assessing comprehension. Also, technology can bring authenticity and real-world problems into the classroom. The teacher, we can facilitate coaching and scaffolding and offer students for self-reflection after they perform their task. Next, when students succeed in science by performing the appropriate task or making the correct deductions from the evidence, it enhances their sense of self and exposing them to think of future careers in science. So, as we know, we need more students entering the field of science. So by promoting virtual environments, we will have more students, hopefully, we hope to have more students engaged and active in learning in science, and that will lead to them choosing a career in science. Okay, so I have 2 discussion questions for you all. The first one is, do you believe that incorporating classroom instructional strategies into virtual worlds and technologies will truly convert more students into pursuing a career in science? Next, do you believe virtual technology has the capability of replacing the role of a teacher in the classroom? In other words, does technology have the potential to successfully execute the role of a teacher? Okay, so here's an example that was in the article. It's called Virtual Reality, where there's a collection of technologies that allow people to interact and learn with 3D databases in real time. So, in the medical field, virtual reality is used to train surgeons. This technology allows students to manage potential problems before they treat real patients in the operating room. So here is a quick video.
When you first think about the virtual reality trainer, you always think that it's a little strange because it's not real life. But I think that practicing those skills, even in virtual reality, is helpful, and it does augment how well you do your tasks in real life when it comes to doing them in the operating room or on the floors. No matter how small these tasks feel when you're doing them on a virtual patient or simulator, they do help you eventually. As you become more comfortable, patients pick up on your comfort level. If you're trying to perform a procedure on a patient and you don't quite feel comfortable with it yet, it shows, and they can tell that you're nervous and whatnot. So I think practicing procedures or whatever task it may be that you're going to be doing on patients that aren't asleep is important to make sure they know they're receiving the best care they can, because they pick up on things like that.
Okay, lastly, I'm going to talk about how I would integrate this topic into a lesson plan. So, my lesson plan is going to be about a lab on genetics. So the objective is students will discover the patterns by which physical characteristics are transmitted from generation to generation by virtually breeding fruit flies. So we are going to go onto this website. It's called sciencecourseware.org, and we're going to enter as guest. So here we have our lab bench. All right. So here we can select male and female fruit flies, and we have the ability to choose their traits. So if we click here, we can order flies online just as you would in real life, and we could choose the traits that they have. So let's say we choose female with a wild type, add to cart, and a male, let's see, with a white eye color, and add to cart, and then we can check out. Okay. All right. So in this virtual lab, the students have to make crosses, and the purpose is they have to see how genetics works. So this is a good resource because in reality, most districts won't provide their students with fruit flies. This is something that students do in college. So this is a good college experience. So this website will hopefully lead students to choose a career in genetics and maybe even fruit flies. The way cognitive apprenticeship comes into this lesson are the teaching methods, like I said before. So the first method is modeling. So I, as the teacher, I would model the cross, the entire experiment one time. So the students can get familiarized with the software, with the website, and get a sense of what they're doing. Then I would let the students work in pairs, and I would walk around and observe them and offer feedback. The next part would be scaffolding. So as the students are performing their tasks, I would ask them questions to make sure they understand what they're doing, and ask higher level questions. After the students are done, the next part would be articulation. So as a class, I would ask a series of questions to make sure that the students understand the task that they just performed in the virtual lab. The next part would be the reflection, where the student analyze their skill performance, so they could analyze what they did right, if they made a mistake, and why. And the last part would be exploration. So this is a step beyond what they did. So if they have any questions, they can think about how they would solve. So any question that they have on genetics, they could do research on their own and figure out how they would solve that problem. And that is it. So I hope you enjoyed this presentation.